By the end of this video, you should be able to explain the purpose of a variable in computer programming. So before we talk about variables in detail, we need to talk about a word commonly used in computer science called a data type. So something you need to know is that data is just another word for information. So when we're talking about data, we're talking about information. And when we're talking about a data type, we're talking about a particular type of information. So when the word data type is used, we're talking about different types of information that can be saved inside of a variable. And there are different types of data that have a different data type. That should make sense to you, hopefully. You know, numbers are one data type and text is another data type. They are different. And Python in particularly behaves differently depending on the type of information or the data that it is working with. So as we save variables, we need to save our variables inside of a specific data type so that Python knows how to behave as it works with this information. So in this video, we're going to focus on three main data types, so three different types of data that we can save. There are more, but we're just going to focus on three here. So the first type we're going to focus on is an integer, and these are numbers that contain no decimal part. So you can see here we have a couple of examples. They can be both positive and negative. Then we have floats, which are essentially numbers that need to contain decimals. And Python does behave differently depending on integers and decimals, believe it or not. And then we're also going to talk about strings, which specifically represent text in quotations. So we're going to talk about how Python behaves for these different data types and how we can use these different data types in our programs. Now you might be wondering why we actually need data types. Why can't we just save a variable in a variable and let Python figure it out? And a part of the reason is because data types tell the computer how much memory to use to store that value. We don't want to waste our memory, and something like a string takes up significantly more memory than an integer. So we want to effectively and efficiently use our memory, and we can do so by specifying data types. The other reason is that data types tell the computer the types of functions it can perform on the data. So for example, if we're trying to use a math operation, we want our computer to know that math operations only work on numbers and they do not work on strings of text. You can't take, 4 times the word hello and, subtract it from the word bye. That doesn't make any sense. That's not how math works. So we need to have data types so that our computer knows that those math functions don't make sense for text. Now, just to really reiterate the memory usage, you can see here that integers take up a small amount of memory, floats take up a medium-sized amount of memory, and strings take up a large amount of memory. So this really puts into perspective why we need to be careful with our memory usage, and we need to utilize data types so that we don't run out of memory as we're writing our program. So variables are how we are going to store all of this information in our programs. So variables essentially are the name of a location in the computer's working memory or its RAM. And it works kind of like a mailbox. So essentially it has an address or a location and it holds the information for us inside of this specific location. So say we create, a variable that holds the integer 12. That variable is going to have a specific name, and in that location, in that named location, it's going to save the value 12 so that we can repeatedly use this value as needed within our program. Now, a couple of key details to know about variables. One is that it can only hold one value at a time. So you cannot have a variable that's going to hold, 3 different numbers in it. It can only hold one. The other thing to note is that when a new value is saved inside of that variable, because we can rewrite them over and over and over again, the old value is completely erased and forgotten. So once you put a number inside of that variable, it is there, but if you rewrite it, the old number is gone and the new number is now there to stay. The third key detail you need to remember is that what type of data that variable holds depends on the first data type it holds. So in Python, if a variable holds an integer to start, that variable can only hold integers moving forward. That's all it can hold. It is a integer variable spot. That is the type of memory and the amount of memory that it has, and it cannot hold, a float or a string. So be very careful and note what type of data each variable you create can hold. Now, while we can name variables what seems like almost anything, there are some rules when it comes to naming variables. First, you need to remember that the names of variables are also called identifiers because that's how we actually identify the variable and the value that it's storing. One thing you need to note about Python is that every name must start with a letter or an underscore. So you cannot start with a number and you cannot start with any other special character. It must start with a letter or an underscore. The third thing is you can only use a combination of letters, numbers, and underscores throughout that name. So you cannot use special characters, like a $ or a pound sign or an exclamation point or anything like that. You can only use letters, numbers, and underscores. The fourth bullet point here states that it cannot contain spaces. So you cannot put spaces inside of your variable name. So if you wanted it to be like first name, you either have to use camel case, which means you do first and then you put a capital N for name, or you could use an underscore and do first underscore name, but you cannot have a space within your name of your variable. The next thing to remember is that they are case sensitive. So upper and lowercase letters are treated differently. So something to note is that using length and then length with a capital L result in different variable names. So be very careful and remember what you named your variables, because if you're not careful, you may accidentally create a second variable with a slightly different name. And then the last bullet point is really just a good practice. Your variable names should be descriptive so that you can remember what they represent. So for example, if you name something sum, we can assume that you're finding the sum of, some numbers being added. Naming variables things like Bob or just giving it a letter like A can be very confusing because you may not remember down the road what those variables actually represent. So be descriptive, be very clear in your variable names and what they represent. So what I'd like you to do here is I'd like you to take a minute, pause the video, and decide which of these variable names are valid or invalid. So take a look at them, decide which ones are valid or invalid, and if it's invalid, make sure that you can explain what rule the name is breaking. And once you think you figured out all 10, you can replay the video and I will walk through the ones that are invalid on the next page. So if you look through here, most of these variable names were valid. Even though A isn't a great variable name and it isn't really descriptive, it is valid because it follows all of the rules. But if we look here in the second one, you cannot have a $ inside of your variable name, so this one would be invalid. You also cannot have a space. That is something that is not allowed in a variable name, so this one would be invalid. You cannot have this little dash. You can only have underscores, so this name would be invalid. Then we also have a dash here, which is a problem, so that one would be invalid. And then you can't start a variable name with a number. Numbers can be in variable names, but they can't start a variable name, so this one would also be invalid. All of the rest of them contain letters, numbers, underscores, and they all start with a letter or an underscore. Now, you do not need to memorize all of these words here, but I just wanted to let you know there are a couple of reserved words in Python. These are an example of a good chunk of them, and these are words that you cannot use as variable names simply because they are used in Python as keywords to represent something else. Now, most of these aren't variable names you would use anyways, as they wouldn't really describe a variable in a program, but just note that if you try to use these, Python will not recognize them as a variable name. So at this point, we're now ready to talk about how we actually assign a value to a variable. And an assignment statement is how we do that. So essentially what an assignment statement does is it saves a piece of information in location. And we're going to talk through what are the different ways in which this might look. So in Python specifically, there are two key details that you need to know. First are all variables in Python must be assigned a value before they are used. You need to make sure that you assign your variable a value before you attempt to use it in your program. Secondly, our assignment statements are going to utilize this equal sign here. So we're going to see how the equal sign can help us assign values and actually save a value in a variable's location in memory. So this is the general format for what your assignment statement will look like. You will always have your variable name here on the left, so make sure this is always on the left-hand side. Okay, so we'll put our variable name there. So let's say, for example, that we had sum as our variable name. So let's write that down below. Then you'll have your assignment operator, which is that equal sign. So we'll put our equal sign. And then from here, you'll have some sort of expression that's going to put a value inside of that variable name. And this is always going to be on the right-hand side. So something you might do is to start, you might say, well, my sum to start is 0, and we're going to change that along the way. Or you might say, well, I have another variable in this particular problem, so maybe my sum is equal to another variable name, whatever, maybe that's, number 1, and we're going to add it together with number 2. So say we have two variables and we're going to add them together. That's an okay way to assign a variable. You can also put just, a math problem in there that it would figure out what the math problem is and save that inside the variable. And depending on if it's a string, say the variable was named name, you could also put a string in there as long as it's inside of quotations, and say I wanted to put my name, I would put Sarah inside of quotations, and that would save that text inside that variable. But that's our general format for this. Variable name on the left, the expression of what you want saved inside the variable on the right, and an equal sign in between. Now, something that can be quite tricky for students in computer science is that an equal sign means something different in computer science than it does in math. So in math, an equal sign means that both sides of the equation have an equivalent value. So this essentially, 6 plus 3 is equal to 9, 5 plus 4 is also equal to 9, and this is saying, yes, this statement is true. However, in computer science, an equal sign really means that the expression on the right is going to be assigned and saved inside of the variable name and the location on the left. So this is an assignment statement. It is not talking about equivalency, so the order matters. Variable has to be on the left, and the value that you want saved in the variable has to be on the right with that assignment operator in the middle. So a couple of key details to remember as we assign our variable values. You must have the variable name on the left. So variable goes on the left. The value in the variable on the left will be replaced by the new value on the right. So the value on the right gets saved inside of the variable name on the left. If the variable previously held a value, it is now gone. So remember, it gets rewritten. It doesn't save any previous values. The values of any variables on the right side, so say we had something like sum equals, number 1 plus number 2. Well, sum here is going to get rewritten with a new value. Num1 and num2 will not change. So if they are on the right-hand side, they are just a part of what's being saved inside of the statement on the left. Then finally, the receiving variable type should have the same data type as the expression on the right. So for example, if sum is an integer, then num1 and num2 also need to be integers added together, being saved inside of sum. They need to have matching data types. So here are just a couple of examples of assignments in code. You can see all of the variable names are on the left. All of the values I want are on the right, and all of these values are going to be saved inside of these variable names. And note, with string values, you do have to include quotes around what you're saving inside of that string variable. So what I'd like you to do here is I'd like you to pause the video, and for each situation below, I'd like you to decide on a variable name, and then write an assignment statement for the variable. So take a minute, pause the video, complete these 3 examples, and then you can continue on to the next slide to check to see if what you created works. So these are just 3 examples of what you might write. Notice that my variable names are very descriptive. So we have length, address, and average. And then I have, values saved on the right-hand side. The first one, it makes sense to use an integer. The third one, it made sense for me to use a float because I'm finding an average and it might not be a perfect integer. And then I used quotations around the address because it's a string and I need to make sure it saves as a string. Now, what's really awesome about variables is variables can and will be reassigned multiple times throughout a program. We can change their value throughout the program and keep reusing them in very specific ways. So as our computer works with the program, those variable values will be changed because as you know, you've exhausted and utilized the one variable value, you might now reuse it to have and hold a different value that you're going to use. And reusing these variables when appropriate, of course, actually just makes our program much more efficient because we don't have an excess amount of variables if we can reuse and reassign with the variables that we already have. So this is an example of reassignment in a particular program. So score starts off being equal to 10, and then later on in the program gets set to 50, and what happens is it basically forgets it was ever sent to 10. And then later on in the program it gets set to 20, and again it forgets that it was even ever set to 50. So we can set score equal to different values and then, do some math or work with those values, and then we can essentially erase it and replace it with a different value that we're then going to work with. So a couple things to remember is you can reassign a variable at any time. It will rewrite what is saved at that location, and that original value will be erased. So keep in mind, score will not remember it was originally set to 10 or 50. It will only remember the 20 at the end of the program. So again, what I'd like you to do here is pause the video and take a look at these 6 statements and decide if these statements, these assignment statements with variable names, are valid or invalid. And if they are invalid, make sure you can identify what the error in the code actually is. All right, so hopefully you took the time to try to figure out which ones were valid or invalid. If you take a look at the first 2, those ones are both valid. They have a good variable name with the variable on the left and what those variables are equal to or being set equal to on the right. In number 3, we have a problem because we can't start a variable name with a number. So because of that invalid variable name, the whole statement does not work. In number 4, this one actually is not valid because I have these flipped around. I need to have my variable name on the left and I need to have what it's equal to on the right and what's being put into that variable name. So they need to be flipped around, and as a result of them being flipped in the wrong way, it's an invalid statement. The same type of thinking applies to number 5. My variable name is not on the left, it's on the right. So these 2 parts of the equation or that assignment statement need to be flipped around. So I need to have answer as the variable name on the left and then the math expression on the right. So this one is invalid. Now number 6 is a little bit tricky. A lot of students think that this is actually an invalid statement, but this is valid. We can essentially take what sum is currently equal to. So say to start, sum was equal to 10. And here we're saying sum is equal to itself plus 4. Essentially what it'll do is it'll take what sum is currently equal to and add 4 to it, and it will then resave sum to be 14. So this is a really convenient way to increment a variable without having to add another variable into the program. So we can increase it and add to itself or multiply it by itself or whatever we need to do. So as long as we recognize that this on the right is a math problem creating a new number that will then be saved in the value on the left. So keep in mind this particular statement right here is valid and is something we will actually use often in computer programming.